was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Throughout its 4.5 billion-year history, our solar system has witnessed carnage on a colossal scale. Time and again, catastrophes have shattered the planetary peace.
A large impact striking at the right location could have caused the whole planet to go off kilter.
Worlds have collided or been paved over by runaway volcanism, or even ejected from the sun's grasp. No planet has provided sanctuary from the solar system's reign of terror.
If you have an asteroid slam in at high speed, then little bits of Mercury will go flying off the surface. And inevitably, some of those chunks will hit Earth.
So if you think Earth is a safe haven, think again. From the oldest cataclysm that rocked the planets to the ultimate disaster that will one day blow them to oblivion, fasten your seatbelts as we count down the 10 greatest catastrophes that changed the planets. Planet Earth, peaceful today, has suffered its share of collisions, massive eruptions, and mass extinctions. But most earthly disasters pale in comparison with the apocalyptic traumas that befell our siblings in the solar system. The solar system was born in a maelstrom as billions of rocky boulders collided to form the planets we know today.
The birth of the solar system was full of violence. There were all sorts of planetesimals and protoplanets colliding with one another or going close past one another and ejecting each other or sending each other down toward the sun. So, you know, only a few planets survived.
The early solar system was very much like a cosmic pinball machine, where you had lots of impacts and lots of collisions taking place, destroying planets, forming planets, breaking apart planets, creating everything that we see today. But long ago, it would not be the type of place that we'd want to live.
As the surviving planets took shape, the violence only intensified. First and earliest on our countdown of the 10 worst planetary cataclysms, the Mercury Mantle disaster. Mercury, the closest planet to our sun, is also the runt of the solar system. Now, scientists think the puniest planet was dealt one of nature's mightiest blows.
Mercury is a mystery to scientists. The iron core inside Mercury is about 40% of the volume of the planet. Whereas on Earth, for example, the core is only about 20% of the Earth's total volume, even though Earth is about 3 times larger than Mercury.
Mercury is a bit of a conundrum in planetary science. It's like the solar system's big ball bearing sitting out there. It's almost like a pure piece of steel. How did that little planet get so dense?
One theory holds that a planetary collision was the culprit. But how could an impact make a planet dense? By envisioning Mercury's cosmic attacker as a cannonball, we can help reimagine what happened.
Let's fire cannonballs from this American Revolution cannon at a bowling ball covered with plaster 40 yards away. Now, that bowling ball covered with plaster represents the early Mercury, where the plaster is the mantle and crust. Now, Gary Harper, our weapons expert, is going to fire this cannon for us. Gary, how do we do this?
Well, fairly simple. We use the appropriate powder charge, insert it into the bore, seat it, Yeah. We take our cannonball, we'll set that in, start it, we'll set that on top of the powder.
How fast is this thing gonna go?
Should be going about 300 feet per second.
Wow, that's about 200 miles an hour. Should do some real damage.
Now, how about some hearing protection, Alec?
Right, and my glasses here, right?
And your glasses.
Okay.
All we have left to do is prime it, and we're ready to fire.
All right, let's fire this cannon.
Okay, fire in the hole.
Oh, yeah! It hit! You blasted it! High five! Woohoo!
We gotta go take a look at that.
Yeah, let's go take a look.
Okay. Wow, there's stuff all over the place
Oh,
here.
yeah, the plaster has been knocked off. Look at that.
This is exactly how scientists think Mercury's crust was blown away, leaving the remaining planet an iron core.
So this nicely explains how dense Mercury is. It has this big iron core because the rest of this stuff was largely stripped away by the collision. So good job aiming the cannon at this bowling ball.
The celestial crack-up would have ejected Mercury's mantle into the sun and flung it as far as Jupiter. The wreckage rained down for up to 4 million years.
The debris went throughout the solar system and could even have landed on planets. In fact, there are some estimates that up to 16 billion tons of material from Mercury landed on Earth.
But proponents of the cosmic hit-and-run theory face a forensic dilemma. If the collision happened, why didn't it leave a visible scar on the surface?
Other ideas for the formation of Mercury's large core involve the local environment of Mercury being so hot due to fluctuations in the solar output that the entire planet actually vaporized. The rocky mantle actually became rock vapor. And then the solar wind blew that rock vapor away out into space. So that's another possible explanation for why the core survived, because it was made of metal and didn't suffer quite the same vaporization as the outer rocky shell did.
NASA's Messenger spacecraft is currently orbiting Mercury, hoping to unlock the mysteries of its turbulent past. But it wasn't just the innermost planet that took a beating. Today, Saturn's spectacular rings rotate in calm serenity. But they owe their beauty to a makeover of the most violent kind, over 4 billion years ago. Number 9 on our countdown of planetary catastrophes, Saturn's shattered moon.
Although Saturn's rings are one of the most noticeable things in the solar system, they've also been one of the big mysteries of the solar system. How long ago did they form? How did they form?
And perhaps most puzzling of all, why are Saturn's iconic rings mostly made of ice? 33 billion tons of it. Sculptor Roland Hernandez has recreated Saturn and one of its icy moons to help us visualize a new theory. How a lunar catastrophe could have given birth to Saturn's rings.
We have a beautiful 2-foot version of Saturn, and we also have its wonderful moon made out of ice.
Wow, it's just beautiful. It looks a little strange, though. It doesn't look like the Saturn that we know because it doesn't have any rings. But that's why we're here, because we want to take ice off the surface of this moon and create rings around Saturn.
Many scientists now believe an ancient ice-covered moon fell into Saturn. As it did, Saturn's powerful gravity pulled off the moon's ice and swept it into orbit.
This sander acts like the tidal force of Saturn, pulling the icy mantle of this moon off and in orbit. The moon itself fell into Saturn, leaving no trace behind, but it left the glorious rings that we see of Saturn today, which are made mostly of ice.
Of Saturn's 60 remaining moons, Titan is the largest. It's 1.5 times bigger than the Earth's moon. But new simulations show that Saturn could have begun with several larger moons that were all lost as they helplessly plunged into the planet, with the last moon creating the bands of rings.
The model really for the first time explains the ice-rich nature of those rings. You know, you'd expect kind of an equal mix of rock and ice and stuff if they were just a battered, broken apart moon, but this whole idea that you had a moon spiral in and had this outer icy mantle stripped off as the rest of the core continues inward, you make the rings out of the icy mantle.
The origin of Saturn's rings illustrates that even its most beautiful features were born in violence. But while the disasters that shaped Saturn and Mercury were localized, one catastrophe ripped the entire solar system apart. It not only affected every planet we see today, it even hurled planets right out of the sun's grasp and into the dark exile of interstellar space. Cosmic catastrophes, like the early disasters that destroyed Mercury's mantle and formed Saturn's rings, have shaped almost every aspect of the solar system. But now, as we move forward in time, disasters even determine the order in which the planets line up. Today, traveling out from the sun, the order of the outer gas giants is Jupiter, Saturn, Uranus, and Neptune. But once, things were very different.
Early in the history of the solar system, Jupiter and Saturn kind of wandered around at different distances from the sun. And that's because they were continually interacting with the leftover planetesimals in the solar system. That affected their orbits.
As the orbits of Jupiter and Saturn fluctuated, they set off a cosmic chain reaction that tore the solar system apart. Number 8 in our countdown to the ultimate planetary catastrophe, the orbital maelstrom. "500 million years after the planets formed, Jupiter elbowed inwards toward the sun, while Saturn, Uranus, and Neptune drifted outwards. Jupiter eventually orbited around the sun exactly twice for every one time that Saturn did. This pivotal moment is known as the 2-to-1 resonance.
2-to-1 resonance is a very strong gravitational interaction when taken over millions of years. And having Jupiter and Saturn in a 2-to-1 resonance leads to profound consequences throughout the solar system. It shakes the orbits of the other objects up, it leads to crossing orbits, and it can lead to giant impacts.
Saturn and Jupiter's resonant gravity destabilized the orbits of Uranus and Neptune. The resulting game of planetary musical chairs ignited the largest and most long-lasting catastrophe ever to shake the solar system.
When Jupiter and Saturn reached that 2-1 resonance, it imparted a lot of gravitational energy that essentially stirred up the outer solar system. Neptune and Uranus were thrown into much higher orbits, and they even switched places. So now the order is Uranus-Neptune. In the beginning, it used to be Neptune followed by Uranus.
Neptune and Uranus may have switched orbits, not once, but several times. But they were the lucky ones. Several planets were most likely hurled out of the solar system altogether, doomed to wander forever in the blackness of interstellar space.
It's almost a certainty that our solar system has lost planets along the way. During this sort of celestial billiards that's played and planets swapping places, there's even some evidence, perhaps, that Jupiter and Saturn may have wandered into the inner solar system to near the position where the Earth is today before wandering back out to their present locations.
But the 2-to-1 resonance was just the beginning. As the gas giants searched for stable orbits 4.1 billion years ago, they ignited the most wide-ranging cataclysm ever to engulf the solar system. So far, anyway. Number 7 in our countdown. The Late Heavy Bombardment. The orbital dance of Saturn and Jupiter didn't just throw the outer gas giants into turmoil. It also ignited a system-wide maelstrom.
The wandering around of Jupiter and Saturn would have created gravitational tugs on the protoplanets that were forming in the region of the asteroid belt. That would have caused them to smash together, shattering them into a bunch of asteroids, probably before 4.1 billion years ago. And then the 2-to-1 resonance of Jupiter and Saturn channeled some of those asteroids into the inner solar system, creating the era of heavy bombardment.
We can see the dramatic results every time we gaze up at the moon. Most of the scars on its pock-marked face are the result of this bombardment, also known as the lunar cataclysm. Proof of this disaster was discovered in 1969 when NASA's Apollo 11 mission put the first man on the moon.
It's a really fun detective story connecting the dynamical models that are giving us an explanation for the geologic evidence that we see for a late heavy bombardment about 4 billion years ago here in the inner solar system. We had the geologic evidence ever since Apollo in the dating of the rocks from the moon that showed this period of dates at that time.
The cratering record tells us that in various spots in the solar system, especially, for instance, on the moon, that there was a sudden increase in the number of really large objects slamming into the planets.
But while the moon merely suffered cosmetic scars, one planet received such a cataclysmic blow, it may have lost its ability to harbor life. Number 6 on our countdown to the solar system's greatest catastrophe. The Mars megameteorite impact. The tumultuous late heavy bombardment that pounded the solar system between 4.1 and 3.8 billion years ago disrupted more than just comets and asteroids. Entire planets were thrown off course. And a NASA space orbiter recently uncovered evidence that one of them, a world the size of Pluto, plunged into Mars, drastically reshaping the red planet.
It was a very large impactor that struck the planet at a very low angle, a very oblique angle, and essentially skimmed off the surface of the northern hemisphere of Mars. Think of it almost as if a knife were slicing through a melon, for example.
The impact carved out the Borealis Basin, which covers over 40% of Mars' surface. It's the largest impact crater in the solar system, large enough to hold the continents of Asia, Europe, and Australia.
We see evidence for impacts on other planets because they form craters that all follow the same sort of pattern. Nice excavated pit, usually a rim around the edge, sometimes a spray of material coming out. But those kinds of evidence were not clear on Mars. The lines of evidence have to do with both the gravity of the interior of Mars and the topography of the surface of Mars. Those taken together show that there was a crater. It was just sort of sunken down on the edges.
At least 5 huge impacts pummeled Mars during the late heavy bombardment. But a far worse fate was in store for the red planet, and our next catastrophe may have done more than gouge out a hefty chunk of the Martian surface. It may have changed the planet's destiny. Number 5 on our countdown, the Mars magnetic disaster. Spacecraft orbiting Mars revealed that the planet carries only the faint remains of its once protective magnetic field. Scientists speculate that the culprit was yet another impact, this one with life-altering implications.
We're not exactly sure why Mars has only a weak magnetic field. One idea is that Mars was hit by a gigantic object, and that heated the crust and mantle, and that decreased the temperature difference between the core and the mantle. Without there being a big temperature difference, there wouldn't be convective motions, the churning motion in the interior of Mars. Without them, you don't get a magnetic field.
On Earth, our global magnetic field deflects dangerous solar particles away from our atmosphere. But on Mars, its very weak magnetic field covers only a few regions of the planet. So deadly solar particles could have eroded away much of its atmosphere.
And over billions of years, you can tend to erode a large fraction of the atmosphere. And that includes things like water vapor, carbon dioxide, things that are excellent greenhouse gases, which have caused the planet to become very cold. And hence, the planet that we see today is a very cold, dry desert.
The loss of magnetism on Mars may have made it impossible for life to evolve and survive on the frigid, arid planet. But some scientists are skeptical that its magnetism died with a colossal bang.
It could be that Mars is simply a small planet, and so it lost its internal heat relatively quickly compared to the Earth. And without the heat, it would have a solid iron core, and it wouldn't create a magnetic field. In any case, once Mars lost its atmosphere, it was unable to support liquid water on the surface because the pressure was too low. Without liquid water on the surface life would have perished.
By the time the late heavy bombardment slowly came to an end, 3.8 billion years ago, every planet in the solar system had received some kind of makeover.
It's very clear that all of the giant planets have moved substantially from where they originally formed. We see that Neptune clearly migrated outward because it picked up the smaller bodies like Pluto and the other Kuiper Belt objects in its gravitational sway and pushed them out along with it.
The planets eventually settled into stable orbits. But now, as they matured, new catastrophes began erupting from within. And in some cases, these volcanic homegrown disasters would exceed anything from outer space. Our solar system was profoundly shaped by the chaotic collisions and bombardments that marked its earliest days. But as the planets finally eased into stable orbits 3.8 billion years ago, new threats arose. And in some cases, they were as bad as anything bearing down from outer space.
Catastrophes in the solar system didn't end with the era of late heavy bombardment. There have been catastrophes since that time. Asteroids and comets can pummel into planets. Rampant volcanism can occur on planets. There are all sorts of ways in which catastrophes can occur on planets.
The next disaster gave one of the planets an ill-fated facelift that left it with the most towering blemish in the solar system. Number 4 on our countdown to the solar system's worst disaster, the Mars super eruptions. The Mars Express spacecraft recently revealed that the red planet has been ravaged at least 5 times by episodes of catastrophic volcanism, giving Mars a unique complexion unlike anything else in the solar system.
In some respects, the shield volcanoes on Mars are similar to some volcanoes here on Earth, such as at Hawaii. You've got a large magma chamber beneath the surface that's erupting lots of lava onto the surface, creating the volcano. However, on Mars, these types of volcanoes are 10 to 100 times larger than they are on Earth. So all across the planet, you've got these eruption events that are occurring here, and then here, and then here. And over time, sort of the whole surface gets filled in with this lava.
Mars is home to about 20 major volcanoes, including Olympus Mons, the largest in the solar system. This towering relic provides an eerie glimpse into the planet's fiery past.
When we look at Mars's geologic record, we can tell how old things are by looking at how many craters are on the surface. If the surface is relatively young, then there has been relatively little time for craters to build up, and so we see a surface that's largely flat and unmarred. If the surface is very old, then we see large numbers of craters. And so through crater dating and through careful mapping of the Martian surface, it looks like there were perhaps 5 very major episodes of volcanic activity on Mars.
Just as with shield volcanoes on Earth, magma chambers rose to the surface of Mars, broke through, and spewed basaltic lava in centuries-long eruptions. But there was a key difference between Earth's shield volcanoes and the behemoths on Mars.
On Mars, there was never large-scale plate tectonics of the type that we have on Earth. And so in Mars, when a volcano gets going, it just sits there and keeps piling lava out and out and out, and builds up enormous shield volcanoes like Olympus Mons.
On Earth, there's plate tectonics. So, for example, the volcanic islands of Hawaii are in a chain because the plate is moving north, the hot spot is relatively fixed, and new islands keep on popping up. But on Mars, it's the same island all the time, and it just keeps getting bigger and bigger.
Massive volcanism radically changed the surface of Mars time and time again. But it wasn't the only terrestrial planet that fell victim to episodes of extreme homegrown violence. Next on our countdown of planetary disasters, the Great Venus Meltdown. Our closest planetary neighbor, Venus, may have begun quite Earth-like. It was born at roughly the same time and made with the same cosmic materials. But something transformed Venus into Earth's evil twin.
If you could penetrate through its thick atmosphere, you'd see that about 90% of the surface of Venus is covered by solidified lava from previous volcanism. And the thick, noxious atmosphere consists mostly of carbon dioxide, and it has an atmospheric pressure about 90 times that on Earth's surface. Wow, that's like being 3,000 feet below the surface of the ocean. That's what you'd feel. Moreover, the temperature on Venus is nearly 900 degrees Fahrenheit. That's huge. It's enough to melt lead. So if a human were suddenly placed on the surface of Venus, he would be baked and very quickly totally crushed.
The hellish conditions on Venus could have been caused by an extreme runaway greenhouse effect over 3 billion years ago.
So what happened to the oceans of Venus if they were there to begin with? Well, the sun gradually grew brighter, and that led to more evaporation of the oceans, increasing the water vapor content of the atmosphere. Well, water is a greenhouse gas, so that led to a greater increase in temperature, which led to more evaporation, more greenhouse gases, a runaway greenhouse effect that eventually evaporated away the oceans of Venus.
Evidence of these lost oceans may exist above the cloud decks of Venus.
We know from sampling Venus's atmosphere that there's a high concentration of the form of heavy hydrogen called deuterium. Most of the hydrogen escaped to space, and the small dregs of hydrogen that did remain are this special heavy form called deuterium.
Venus provides a great example of what can happen to a planet when the climate changes dramatically. If we are able to understand what happened on Venus, we can apply those lessons learned here on Earth.
If an eco-disaster evaporated the liquid surface water on Venus, were there living creatures that also perished? That's what one viewer wanted to ask the universe. So Jack Kershaw from Fort Worth, Texas, emailed us. Did life once thrive on Venus?
Jack, that's a really fascinating question. It turns out that Venus may have had oceans for the first 500 million or billion years of its existence. If so, primitive life, by which I mean microbes and bacteria, may have formed in those oceans. We just don't know. But on Earth, primitive life formed shortly after the end of the late heavy bombardment. If the same thing happened on Venus, then Venus once had life.
According to the greenhouse theory, the surface of Venus became bone dry gradually over millions of years. But not everyone agrees. Some scientists argue that the water on Venus actually disappeared not slowly, but in one disastrous day. Of all the catastrophes that have swept the solar system, perhaps the most puzzling is what happened to Venus, a planet originally so warm and Earth-like it might have harbored life. For decades, scientists theorized that a runaway greenhouse effect slowly raised the planet's average temperature to a scorching 860 degrees Fahrenheit, almost double that of Mercury. But Earth's next-door neighbor may have taken a different road to ruin.
One way that Venus may have lost a substantial chunk of its water all at once is through a giant impact. A giant impact will hit the planet, basically strip off a huge amount of the outer layer. That provides an incredible amount of energy, an incredible amount of heat, and so volatile elements like water or ammonia or methane are simply lost to interplanetary space, and after the giant impact has occurred, after everything has died down, you're left with a planet that's much drier and made of material that has a much higher vaporization temperature.
Proponents of the theory claim the cosmic punch was so powerful, it actually spun the planet off its axis.
Venus spins in the direction opposite that of most of the planets. And we don't know quite why that is, but one idea is that it was hit by a gigantic object early in the history of the solar system, and that effectively either flipped it or just reversed the sense of rotation, depending on exactly how the object hit Venus.
The fate of Venus is a telling reminder that even temperate conditions like those on Earth can never be taken for granted. If we didn't know that already, number 2 in our countdown of planetary catastrophes drove the point home, and this time the whole world was watching. The Shoemaker Levy 9 impacts.
We used to think that the outer planets were pretty stable. There wasn't a lot happening to them. But in fact, now we see impacts hitting the outer planets all the time.
Jupiter, the largest gas giant, has been our solar system's planetary punching bag. Its gravitational force deflects renegade comets that break loose from their orbital prisons in the Oort cloud and Kuiper belt.
The rate of impacts on Jupiter is greater than that of any other planet for 2 reasons. First, Jupiter is the biggest planet, so it presents the biggest cross-section. Things are more likely to hit it. Second, Jupiter has a huge mass, so it pulls objects in toward it. In a sense, Jupiter is asking for trouble.
Jupiter has taken a lot of nasty hits, including one of the most violent celestial catastrophes ever witnessed by mankind. In July 1994, the world watched as a chain of 21 comet fragments raced towards the giant planet and struck it with colossal force. Shoemaker Levy 9, named after its discoverers, delivered the energy of 6 million megatons of TNT.
During the Shoemaker Levy 9 impact on Jupiter, you had this ripped-up comet coming in at tens of kilometers per second and impacting Jupiter in one airburst after another as Jupiter spun underneath the comet. And so that led to a series of impacts being spread along a particular latitude of Jupiter's surface and leaving these scars, which were visible in telescopes from the Earth.
The fragments didn't produce craters because Jupiter doesn't have a solid surface. Instead, they struck the gas giant's dense atmosphere, dredging up material that erupted in a trail of venting scars.
The impact scars, the dark cloud features, were about the size of our planet Earth. And that tells an important tale, that if you have an object that's, half a mile across striking an object the size of the Earth, the dust fall from that impact will encompass our entire planet. So that's the lesson we learned from the Jupiter impacts, is it really brought home the story of impacts right here on Earth.
The dark imprints left on the cloud decks of Jupiter were only visible for several months before being mixed into its turbulent atmosphere.
Jupiter has very vigorous and oftentimes very violent weather patterns. So no matter how destructive that airburst might be, over a period of weeks to months, the currents, the airflow in Jupiter's atmosphere takes the pollutants and disperses them through the planet, and the evidence for the catastrophic impact dissipates and disappears.
Shoemaker-Levy 9 is a scary reminder of the cosmic unrest in our solar system. But scientists warn that the ultimate catastrophe still looms in the future. And for Earth, there can be no escape. Our solar system has weathered over 4 billion years of planet-altering catastrophes. In some cases, the effects are obvious, like the craters of the late heavy bombardment that still litter the moon. In others, the evidence has long since disappeared. But scientists recently discovered that number 2 on our countdown of catastrophes has created a ripple effect they never imagined. NASA has recently compared images of Jupiter from the Cassini and New Horizons missions and made a stunning discovery. Like Saturn, Jupiter also has rings, though much fainter. But something has disrupted them.
If you look at the rings of Jupiter, they actually have little corrugations, little ripples in them. And those ripples are formed when a portion of the ring is tilted, and then as it continues to spin and evolve over time, those ripples wander out, propagate out through the ring system. If you unwind that system and work back out the ripples, you can find out the point in time when that ring plane had gotten tilted over. That point when that ring got tilted was right around July of 1994.
July 1994 marks the date of the Shoemaker-Levy 9 impact event. The scientific sleuths had made a key discovery. As the cometary fragments struck Jupiter itself, much smaller debris passed through its rings, tilting and twisting them into the ripples that we still see today.
In the case of a disrupted comet like Shoemaker-Levy 9, you've got an entire pall of dust, a large mass of material distributed across the disk of the rings, raining through that system. And so rather than displacing only 1 or 2 ring particles, you can do the entire cloud at once, tipping it on the side.
Shoemaker-Levy 9 wasn't the only comet to leave its calling card mark on Jupiter in recent times. In July 2009, another asteroid smashed into the gas giant near its south pole.
When it impacted Jupiter, it brought up a lot of material from deep within the atmosphere and created a huge scar on the surface of the planet that was visible for many weeks. The size of this black ash cloud was perhaps the size of the Pacific Ocean on the Earth. It was quite large.
It's now estimated that an asteroid or comet hits Jupiter every 10 to 15 years, which is 5,000 times higher than the rate of impacts on Earth.
The fact that we've seen several of these suggests it's happening all the time because they're all the ones we don't see. So there's a lot more impact activity on the outer gas giants than we ever thought.
If Jupiter was not in our solar system, the Earth would be essentially a sitting duck for all the debris, the comets and the asteroids that were falling in towards the sun, creating vastly larger numbers of catastrophes on Earth than we've experienced through our history.
But as our solar system ages, new threats will likely arise, and Earth itself will face a cosmic day of reckoning that nothing, not even Jupiter, can prevent. Which brings us to number 1 on our countdown of catastrophes: planetary Armageddon. In several billion years, many scientists believe Jupiter, the largest planet, and Mercury, the smallest, will face off in an orbital duel. And an innocent bystander, Earth, just might find itself in the line of fire.
Right now, our solar system is kind of the paradigm of clockwork regularity. But it turns out that the planets do affect each other gravitationally. The planetary orbits are over very long periods of time vibrating in and out and turning. Jupiter and Mercury will begin to turn their orbits at the same rate. And if that happens, Mercury's orbit becomes progressively more eccentric. It becomes progressively more elongated until the point where at its far point from the sun, it's actually crossing Venus's orbit. If Mercury's orbit ever gets to the situation where it's crossing Venus's orbit, then basically all hell can break loose.
Scientists have calculated 1 of 4 disastrous consequences. Mercury might collide with the sun, might be ejected from the solar system, might smash into Venus, or in a worst-case scenario, Mercury might collide with the Earth, blasting away our mantle and atmosphere and sterilizing our planet.
As far as we can tell from computer simulations, there's about a 1% chance that Mercury's orbit will go haywire. And within that 1% chance, there's a small probability that things will unfold in such a way that the Earth itself is impacted by Mercury.
Mercury is hardly the only threat we face from within the solar system. According to some scenarios, Mars also faces orbital chaos in the future, and it too may slam into Earth, repeating the disaster that gave rise to the Moon. And it's not just planets. Nearby stars periodically disrupt comets in the Oort cloud, which could send them on a kamikaze mission through the solar system and set off a new late heavy bombardment. And if, as most expect, the Andromeda Galaxy ultimately collides with the Milky Way, the galactic pileup could shatter our solar system's deceptive calm.
The ultimate planetary catastrophe, I think, is still in our future.
Catastrophes have always played a violent yet vital role in our solar system's history. Without them, our neighborhood would be a very different place. By learning about these volatile events, we can better understand how they helped form the planet that gave us life, and how we might protect it and us from the catastrophes of the future.